welcome to the core first semester final review. Okay, number one. Some students work as volunteers at the animal shelter. The table shows the number of hours each student volunteered for 1 month. Determine the 5-number summary of the data. Now this can be done in your calculator. There's a nice fancy schmancy way that we are happy to help you and show you. I'm going to do it by hand here because honestly I don't know how to make the screen recording record the calculator app and my OneNote at the same time. So if you want to know how to do this on your calculator, ask your teacher. So let's do it by hand. In order to get the 5-number summary, I'm going to list the numbers from smallest to largest. So you do that too while I do that. So I have 2 5s on my list. So there's 2 people, Mike and Elsie, that volunteered 5 hours. When you have more than one of the same number, you do need to write it as many times as you see it. So there's 2 7s as well. Okay. Now the 5-number summary is the minimum, Q1, medium, Q3, and maximum. I like to begin with the minimum, maximum, and the median. I don't know why, that's just how I like to do it. Okay. The minimum is the smallest number in the list, 2. The maximum is the largest number on our list, 11. The median is the number in the middle of the list. Find the number in the middle. Now the way I like doing this is by crossing the numbers off, one from each end. I think this is like the way you did it in middle school when you first learned about it. This is what I mean. I'm going to cross a number off each end of the list until I'm left with 1 or 2 in the middle. So we'll see what we have. Oh, wonderful. It looks like our median is 7. Next, let's find Q1 and Q3. Q1 is the median of the left side. Q3 is the median of the right side. Let's find them. So first I'd like to find Q1. I'm going to use the same method just with the numbers on the left. Now when you have a median, like an exact number that's in the middle, you ignore it and you're just using this area to find Q1. Let's do it. Wondrous. 5 is Q1. Let's do the same thing for Q3. Remember, you're just looking at this side. Cross 1 off from each end. 9 is Q3. Number 2 asks us to use the same data from number 1 and find the IQR. The IQR is actually Q3 minus Q1. So let's do that. Q3 is 9 minus Q1 is 5. So our IQR is 4. Number 3, calculate the mean and sample standard deviation of the data set. Now this can also be done in your calculator, and I can easily tell you how, and I think you should use this method when you're doing the final. Just in general when you're doing statistics, because it's faster. To find the mean, you go Menu, make sure you're in the Calculate section, 633, make sure to click your CTRL button and your backwards parenthesis to make the squiggly brackets appear. When that happens, put in the numbers you see in this box and make sure to put commas in between them. There is a comma on the bottom of our calculator that you can use as part of that keyboard. Go ahead and enter it in. Maybe pause the video while you do so I don't give it away right away. But the mean is 13 when I did it. Standard deviation is very similar. Menu 637 and CTRL backwards parenthesis. these need to appear for this to work. Otherwise, this calculator gets confused, doesn't know what's happening, freaks out, and says error. So go ahead and pause the video while you enter it. Don't forget commas. And I will tell you the answer to it in a minute. Well, more like a second. It's 7.46. And I believe I rounded that answer. Number 4 is the same. Calculate the mean and sample standard deviation. So for the mean, it's the menu 633. So go ahead and do that. Pause the video. And I'll write down the answer once you unpause it. This is fun pretending you're pausing. It's 47.5. Standard deviation, same idea. Menu 67, control button, backwards parentheses. Put in your numbers with commas. I'm assuming, or hoping, you're pausing the video to try to do this on your own to practice it for finals. Your standard deviation should be 35.23. Number 5, determine any outliers in the data set. Okay, to find outliers, we have 2 special formulas. And just to remind you, outliers means numbers that don't quite fit with the data. In order to find them, we have 2 types of outliers, actually. We've got lower fence outliers. That's when we have Q1, or we do Q1 minus the IQR times 1.5. To find if there's any number smaller than that. If there are, then they're outliers on the lower fence. We also have an upper fence to see if there's numbers too big for our data. This is Q3 plus IQR times 1.5. So it looks like we need a couple of things before getting started. We need Q1, Q3, and our IQR. Okay, in order to find Q1 and Q3, the first thing we need to do is find the median. So let's do that. So I'm going to cross numbers off each end. Boom. This pen is too thick. I don't like it. Let me unthicken that. All right. Perfect. Wonderful. We have a number in the middle. Okay. To find Q1, we need to find the middle of the left. So I'm going to use that same method. And we're stuck with 2 things. Now the way we find the mean or the median when we have 2 things, the median, when we have 2 numbers in the middle, is we add those 2 numbers and divide by 2. 5 plus 5 is 10. 10 divided by 2 is 5. So our Q1 is 5. Great. Let's find Q3. I'm going to cross off each side. Oop. Stuck with 12 and 16. Let's find the number directly in the middle of 12 and 16 by doing 12 plus 16 divided by 2. So that's 28 divided by 2, which is 14. And now that we found Q1 and Q3, we can find our IQR by doing 14, our Q3, minus 5, our Q1. So what's 14 minus 5? It's 9. So our IQR is 9. Do I want to color code it? I'll just highlight it. Okay. What do I want to highlight it with? Yellow? Yeah. Yellow looks good. Okay, so first things first, let's do 9 times 1.5 to make our calculating a little bit easier. Although actually, you can put this in as a sentence into your calculator. You could just click 5 minus parenthesis 9.5, 9 times 1.5. When you do that, you get negative 8.5. Are there any numbers in our data set that are smaller than negative 8.5? The answer is no. The smallest number we have is 4. So none on the lower fence. Let's do the upper fence. So in your calculator, enter 14 plus 9 times 1.5, and you should get 27.5. Do you see any numbers on our list that are larger than 27.5? Why, yes. 30 is our outlier. Number 6, which plot is symmetric? Now, in order to determine if a dot plot is symmetric or not, we want to kind of think about it like a hill. A hill is symmetric if it's perfectly in the middle. It's skewed if it looks like this, or maybe the top of the hill is on the other side. So we want a perfect kind of, well, as perfect as we can get, upside down U shape. So to solve these problems, I actually like to trace the dot plot and see what shape it gives us. All right, letter A. That looks symmetric to me. Just for good measure, and if I was taking the final and A was my right answer, I would check B and C and D as well. So let's do that. When I check B, no, that doesn't feel symmetric. Nope. No. Okay, letter A it is. Again, it might be obvious for some people. If you're not that visually strong with seeing things like that, that's fine. Just go ahead and trace it. It'll be way easier to see. All right, number 7. A coffee shop manager records the combinations of coffee and sweetener ordered one day. Which combination was ordered the least? Okay, so all of our combinations happen right here. Let's make this a little thicker. These are all of our combinations. So black coffee with whatever sweeteners, sweeteners with whatever coffees. So let's find the smallest number out of them. Right here, there's the 2. So the least popular coffee combination looks like it's coffee with soy milk and artificial sweetener. All right. Number 8. According to the table, which type of pizza did the shop sell the most? Type of pizza. That's important. Type of pizza only refers to cheese, veggie, pepperoni, and everything. So I don't care the type of crusts. So I'm not really looking at combinations. I'm just looking at totals. So let's look at the totals for all of these pizza possibilities. I want the most, so the biggest fraction, the biggest decimal. It looks like it's cheese. Cheese was our most popular type of pizza. Number 9. At which vending machine were candy bars least popular? Okay. Oh, I didn't erase this part from the last time I was doing this. All right, so candy bars. That looks like it's the second darkest. So this box right here for each of them. Okay. I can see it now a little better. In vending machine A, it looks like candy bars were the most popular, so no. What? Were those even words? Vending machine B, that's the candy bar part, but you know what? It looks like each part is about the same. So vending machine B doesn't have a most or least popular. They're all pretty even out. Ooh, vending machine C looks like it has a big chip section, a big granola section. Let's compare the nuts and candy bar section. They look about the same. So maybe? Let's check letter D. Letter D, similarly to B, they're all the same. So I'm going to go with vending machine C. Number 10. According to the graph, what percentage of visits to the weather topic was from people in the Southwest? Southwest, Southwest, that's the one on the bottom, the lightest one. Okay, so I'm looking just at the weather bar, and I want to see what percentage this is. And it looks like this cuts off right about there. 10%. All right, number 11. A hospital is trying to revamp their menu so they could collect data on the foods that patients prefer. The graph represents the data. based on that data, decide if each statement is true or false. To help my own self, I'm going to color code this because this is really trying me. I'm going to make the lightest one, the chicken one. Let's make that purple. I'm just going to write a purple C in there. I'm going to make this one burgers. I'm going to make it blue. I'm going to write a B in it for burgers. Then I'm going to make pizza green and put a P there. Okay, and pasta can remain the darkest color. Okay. The most popular food is burgers. Well, you know what? If we want to figure most and least popular, let's find how many % of people surveyed enjoyed each of those. Okay, let's begin with, let's go bottom to top. Let's start with children. Pasta. That looks like it's a little bit below 15. Let's say 14 for pasta. Pizza. That looks like it's 5, 10, 15. Oh, let's give it another one. Let's do 16. B for burgers. That looks like it's a little less than 5, 10. So, I don't know. Let's give it 9. And chicken, 5, a little bit. Let's give it a 7. I'm guesstimating here. Let's do the same thing with adults. Ooh, adults have a perfect portion of pasta lovers. 15. For pizza, it looks like, ooh, it's just above there. So 5, 10, maybe, I don't know, 11 or 12. Burgers, 5, ooh, I think this would be a nice 10. And chicken, 5, 10, well, let's say it's 15-ish. Okay, the most popular food, is it burgers? No, it doesn't look like it's burgers. That's just 9 and 10. That's 19 total. So 19 for burgers, 22 for chicken. I'm just adding across. Ooh, pizza. Of course it's the most popular, 28. Ooh, almost 29, pasta. Okay, so I'll say this is false. It's not the most popular food. The least popular food is pasta. No, that's also false. I think the least popular food is burgers. Yeah. Children most prefer pizza. Yeah, true. I guesstimated 16 there. Most adults prefer chicken. More adults prefer chicken than children. Yeah, true. Adults most prefer pizza. No, false. They prefer pasta. More adults prefer pizza than children. For a second, my brain processed that. Not the way we're supposed to think about it. We're not going to eat people. Most adults prefer pizza than children. So, where is our pizza? That's 12 and 16. No, I would say more children prefer pizza than adults. So false. All right, onwards we go. Ooh, use the table to answer questions about the pet store sales. Okay. A, which type of pet did the pet store sell the least? So I'm going to look at the totals of pet sales, and it looks like the smallest pet sale, looking right here, is other. Okay. Which type of pet did the pet store sell most? It looks like dogs had the largest percent. Which gender did the pet store prefer? Oh, sell, not prefer. That'd be weird. We're going to look at the genders right here. And it looks like male were most sold. Number 13. Determine if each graph represents a function or not. So, go ahead and try to do that. I recommend using the vertical line test. Go ahead and draw some vertical lines through each graph. I like to draw more than one just for good measure. Okay. The first one on the left. This vertical line only crosses once. This one only crosses once. It's a function. Second one. These lines cross twice. Not a function. Third one. Once each. Function. Fourth one, crosses twice, not a function. So how can we tell which were not functions? The vertical line test failed and crossed the graph more than once. Oh, that almost looked beautiful. Let's try writing once again. There we go. Now I know my handwriting isn't the most perfect, so I'll just read it out loud. The vertical line test failed and crossed the graph more than once. That's how we know that the ones we said were not functions aren't functions. Now, can we graph the ones? Clearly, they're graphed, and you'll actually learn about them next year. But they're just not functions. Number 15. Determine if each table represents a function or not. All right, look at letter A. Is it a function? It is! Letter B, is that a function? It is! Letter C, is that a function? It is not. It is not a function. Number 16 is asking us how we know. Because the x's are repeated. Can you see where the x is repeated? Right here. There are 2 3's. Now, letter B is a tempting one for students to say, no, look at all those 3's. Y can be whatever it wants. And letter A, for a lot of students, they say, well, 4 happens twice. It only happens once in the x's. That's all that matters. The y's are important, just not whether or not it's a function. Number 17, identify the domain and the range. The way we do this is by writing the domain and range as a set of numbers from smallest to largest. The domain refers to our set of x's. So I'm going to use my little squiggly brackets to represent a set, and I'm going to write my numbers in order from smallest to largest and close my set. Your range, that is your y's. Again, make sure to make them smallest to largest. So we have 0, 4, 8, 10, 12. Let's do the same thing for the second one. Our x's represent our domain. Why aren't we writing? Uh-oh. Okay. Whew, scared me for a second there. All right. So from smallest to largest, 1, 2, 3, 4, 5. Close your squigglies. And then our range is our set of y's. Again, smallest to largest, 1, 2, 8, 16, 32. Closing my squigglies. You know, as long as you attempt to draw your squigglies right, I can't blame you. I mean, mine never come out perfect. Ooh, number 18 asks us to identify the range given the graph. Now, when we look at range, we only look at our y's. So I'm going to go from the bottom of our graph to the top of our graph. All right, so the bottom of my graph looks like it's at 2, and the top 8.25? It's more than 8, less than 9, less than 8.5. I'm just going to guesstimate, okay? So our range, 2 is our smallest, and I'm going to guesstimate 8.25. I think that's a solid answer. Okay, that's our range. Number 19, let's complete the statement. Each figure has blank than the one before it. Remember, our images, our figures, go left to right just like we read in English. So look at the pattern from left to right and see if you can determine what's happening. My hint is to count the dots. This has 2 dots, 4, 6, 8. So each figure has 2 more circles than the one before it. 20. Determine if each sequence is arithmetic or geometric, and then tell me the next term. I don't really have room up there, so I'm going to work down here. In order to see if something is arithmetic or geometric, we find the common difference, see if it works, and then find the common ratio and see if that works. I'm going to start with common difference. In order to find the common difference, we do second number minus first number, and that should tell us our pattern. So 1 minus 0.1. 1 minus 0.1 is 0.9. It's positive. That means it says add 0.9. Okay, well, let's see if that pattern works. If I do 1 plus 0.9, does that give me 10? No. Well, if it's not arithmetic, well, it's definitely geometric. So I know at least I know at least to circle this one, but I can't find the next term until I figure out my common ratio. In order to find my common ratio, I do something similar, except this time I do second number divided by first. So what's 1 divided by 0.1? You should get 10, and that means multiply. So 100 times 10 is 1,000. All right, letter B, same thing. Let's find the common difference, see if it works. If it doesn't, let's try the ratio. We're going to do first a second number minus first number, second number, 1, minus first number, 0.8. 1 minus 0.8 is positive 0.2. Got scared of me. That means we add. Let's see if that pattern holds up. Is 1 plus 0.2 1.2? Yes. Let's try one more time. Is 1.2 plus 0.2 1.4? Indeed. So this is arithmetic. Let's add 0.2. Our next term is 1.6. All right, letter C. Same idea. Let's do the common difference. If it works, sweet. If it doesn't, we will try the common ratio. Okay, so for the common difference, we're going to do second number, negative 204, minus first number, negative 173. Negative 204 minus negative 173 is negative 31. That means we're subtracting. Okay. Is negative 204 minus 31 negative 235? It is. Let's try another time. Is negative 235 minus 31 to negative 266? Yep. It's arithmetic. To find the next term, I'm subtracting 31, and I get negative 297. 21. Novi Elementary School has 2 disposable masks left on the playground. After Monday, there are 8 masks on the playground. Tuesday, 14. Wednesday, 20. If it continues, how many will there be on Sunday? Okay, well, let's find our pattern. I'm going to highlight the numbers so I can see them a bit better. Okay, so 2, 8, 14, 20. Just like last time, the problem right before, I'm going to see if there's a common difference. I'm going to do 8 minus 2. That's 6, so that means we're adding. Is 8 plus 6 14? Yes. Is 14 plus 6 20? Yes. Okay, so we have, which one's Monday? So this is Monday, Tuesday, Wednesday, we need Thursday, Friday, Saturday, Sunday. Okay, so let's keep adding 6. 26, for Thursday, 32 for Friday, 38 for Saturday, and then on Sunday, at the end of the day, there should be 44 masks. Number 22. The Chicago Bulls franchise has agreed to pay $1,000 to Morton West High School to remodel the weight room. Oh, I wish. In addition, they will donate $200 for every sports team that makes it to the playoffs at Morton West High School this school year. The sequence shown represents the possible amounts that the Chicago Bulls franchise will be donating this year. Let's write a function to model the situation. Here's what we're using. So this is the explicit formula. So to begin with it, we need A1, so AN equals. A1 is my first term, so 1,000, plus our pattern. Well, the pattern is right here in the problem. It's 200. That's how much we're getting each time. Now, I'd like this to be as a function. So I want it to be function notation. So that means I'm going to rewrite it as f of x equals 1,000 plus 200, parentheses x minus 1. I'd go from n's to x's. And of course, function notation instead of an. What should my next step be here in order to simplify this a little bit? Hopefully, you're thinking of distributing. So we have 1,000 plus 200 times x is 200x. 200 times negative 1 is minus 200. Thank you. Whoops, that's an extra 0. One more step. Let's combine some like terms. Do you see what terms we need to combine? It looks like the like terms we can combine is 1,000 and minus 200. So our 200x stays by itself. 1,000 minus 200 is 800. 23. Use the following graph to find the average rate of slope. What average rate of slope? Average rate of change. Our average rate of change is rise over run. We just need 2 beautiful points, and we've got so many. We go from the left point to the right point, and really, it doesn't matter which 2 points you use as long as you're going left to right. Okay, to go from left to right, I need to go down. I need to go down 1, 2. So my rise is negative 2. The negative means down. And I'm going to the right, 1. Our slope is negative 2 over 1. To find the average rate of change from a table or from x's and y's, we use the following formula. y2 minus y1. Oh, you know what? I'm going to use highlighters. I'm not going to color code this. y2 minus y1 over x2 minus x1. And that just means first y, second y, first x, second x. Okay, let's do some color coding. Let's begin with x1 and y1. That's my first x that I feel like using, and that's the first y. This is the second x, and this is the second y. All right, let's do this. So y2 is negative 4 minus y1, negative 14. x2 is negative 2 minus x1, which is negative 4. All right, let's do that in your calculator. Negative 4 minus negative 14 is 10. Negative 2 minus negative 4 is 2. 10 over 2 is 5. If you can't simplify it, do it. All right, let's do this again for letter B. I don't know why I made the fraction line that long. y2 minus y1 over x2 minus x1. Let's color coordinate again. x1, x2, y1, y2. Why did I put the blue and green together? It's fine. It's fine. It's fine, Gumin. It's fine. All right, let's do this. Y2 is 30. I don't even remember which color I use now. Shoot. I'm gonna not color in the Y's because I can't tell the difference right now. I have a blue screen. You know what? I'm gonna do this. I'm just gonna relabel them. This is my video. I can do whatever I want. Oops. Sorry, that was my computer. Alright, I'm gonna make Y1 green and Y2 is blue. Okay, so then Y1 is green. Okay, 45. Alright, and I can tell the difference between those colors. X2 is -6 minus X1, which is -11. Yellow. Alright. 30 minus 45 is -15. -6 minus -11 is +5. Simplify it, because we can. -3. Alright, 25. Determine if each chart represents a linear function or not. The way we do this is we see if there is a pattern between the y's and x's, of course. So for 25, for the first one, it looks like we're adding. What was that? Why you do that? It looks like we're adding. That's just rude. You guys see that, right? I'm not crazy. It's moving. Maybe I am crazy. It looks like we're going by ones here. So I would say this is fine. This is beautiful. Let's take a look at the y's. To get from linear functions go by addition or subtraction. They're arithmetic. So to get from 1 to 4, I add 3. To get from 4 to 9, I add 5. Not a linear function. All right, here my x's go by +1. Perfect. Here, go from 12 to 15, I add 3. 15 to 21, do I also add 3? No, I had 6. Darn. Not linear. Let's try this one. This one also looks like it's increasing by 1s for the x's. To get from 18 to 14, we actually subtract 4. To get from 14 to 10, -4. To get from 10 to 6, also -4. Okay, that one's a function. 26, let's rewrite each expression using the distributive property. When we distribute, we multiply. Let's do it. 5 times x is 5x. 5 times +4 is +20. 2 times x is 2x. 2 times -4, negative. I don't know why I wrote 16. I know it's -8. You know what? I'm just going to blame the length of this video. Alright, so letter C. The first thing that we're going to do is multiply -3 times 2. Oh, -3x times 2. And that gives us -6x. And then -3 times -7 plus 21. Number 7. No, 27. I knew that looked weird. Okay, let's solve each equation to determine the solution. The first thing I like to do is draw a little line down the middle. Okay, what do you think the first step should be? The first step that I'll take here is to distribute this 6. So now we have 6x minus 30 minus 16 equals 2. What's next? The next thing that I'll do is combine the like terms over here. I'm going to subtract 16 from -30. Now, when numbers or variables are on the same side and you can combine them like terms, you don't have to do the opposite operations. So, we have 6x minus 46 equals 2. Next, let's add 46 to both sides to undo the minus 46. On the left, they're gone. We are left with 6x equals 2 plus 46 is 48. And our last step, divide both sides by 6. X equals 8. Letter B. Oh, this one starts off very similarly. Let's start off by distributing this negative 8. Negative 8 times x is negative 8x. Negative 8 times negative 3 is positive 24. Then I bring down the minus 7, the equals, and the 73. Next, let's combine some like terms. We can combine the 24 and the minus 7 because they're both regular numbers. So we have negative 8x plus 17 equals 73. What do you think the next step should be? The next step I'll take is to subtract 17 from both sides to undo the plus 17. So on the left side, we have negative 8x. On the right, we have 56. And our last step here is to divide both sides by negative 8. X equals negative 7. Oh, letter C. Oh, this is a nice one. Line down the middle. What do you think that first step should be? The first step that I'll take here is to add 3 to both sides. Whoops, Gumin, use the purple one. Use the purple one. What did I undo on top there? Okay, so I am going to add 3 to both sides. So on the left, I have negative 7x. And on the right, I have negative 35. Let's finish this problem by dividing both sides by negative 7. X equals positive 5. If you just heard a burp in the background, that was my dog. I'm recording this at home. Sorry about that. Letter D. What do you think the first step should be? I'm going to get started by subtracting 5 on both sides. On the left, very careful here, we are left with negative 4x. It's very easy to lose that negative. And on the right side, we have negative 44, because that's what negative 39 minus 5 is. And we finish this problem up by dividing both sides by negative 4. X equals 11. All right, letter E. Ooh, we got some like terms that we can combine. Let's do it. What terms can we combine here? Do you see them too? What I see is the 10x and the 2x. 10x's plus 2x's is 12x's. Again, they're on the same side, so I just follow the operation that's in between them. What should we do next? Let's add 14, because that's undoing the minus 14. That means on the left-hand side, I am left with 12x. And on the right, 22 plus 14 gives us 36. And of course, we finish up with our favorite last step, division. I know to divide by 12 because that's the number next to x. X equals 3. Letter F. Ooh, okay, so we have x's on separate sides. I'm going to show you the way that I prefer to start this problem. You can actually start this problem 4 different ways. I like to move the x's around first, or whatever variable it is. So what I'm going to do is subtract 2x from both sides to get my x's to the same side as my larger x's. That's how I decide on my first step. And again, this is personal preference. It really doesn't matter how you start this problem. All right, 7x's minus 2x's is 5x's. I bring down the minus 25, and 175 is left over on the right. What do you think our next step should be? I'm going to add 25 to both sides. So that's undoing that minus 25 on the left. So I have 5x equals 1. What? Why did I write a 1? Silly goose. It's 200. And of course, let's finish this problem up by dividing both sides by 5. X equals 40. Not bad. I feel like this is probably going to be the strongest for you guys because this is the most recent thing we did. Ooh, okay, word problem. Oh yeah, 29 and we're done. Look at you guys. We're almost done with this review. Ethan saved $77. He already spent $9. He plans to spend $4 on Starbucks coffees each week to treat his teachers. Aw, isn't Ethan so nice? Choose the inequality that represents the number of coffees he can buy. And we're using C for coffee. Okay, the first thing I look for is that all of them have 77 on the greater than side. And it looks like they all do. Okay, so 77 is the max, so we can't go more than that. I think all the symbols and all the 77s are good. Okay, so he already spent $9. And the way we did this in class is we made sure there's a plus 9. So let's find the plus 9s and cross off whatever else there is. Okay, so that gives B and D left over. Now he's going to spend $4 on Starbucks coffee. If it's on that plus 9 side, we need to make sure that 4 is also positive for coffee. So letter B is our answer. All right, 29. Let's solve the following inequalities. So solving inequalities is very similar to solving equations, except we can graph it and that tiny, tiny rule about dividing by negatives. All right, let's do letter A. The way to solve this inequality is to divide both sides by -5. Now, if we divide by -5, remember, that's that special rule, we have to flip our symbol. So, our symbol faces the other way, so x is less than -6. Because we have a symbol like this, why did that turn out pink? I selected the black marker. There we go. When we have symbols like this, remember we have an open circle, and the or equal to's get a filled in circle on the graph. So, -6 in this problem gets an open circle. X is less than -6. So, we point an arrow to the left. The way I remember this always is less is left. All right, letter B. Once again, I'm going to divide, but this time I'm dividing by a positive number, which means my symbol stays the same. X is greater than or equal to -2. -2 gets a filled in circle. Oops. How did I just delete that? That was bizarro. All right, filled in circle, -2. Greater than is an arrow to the right. Whoops, I drew this too low. That's fine. Letter C, is this our last one? Oh my goodness, let's do it. I'm going to start this problem off by adding 6 to both sides. I'm left with -2x is less than or equal to -2. And I'll finish this problem up by dividing both sides by -2. And remember, we just divided by a negative, so our symbol flips. -2 divided by -2 is +1. So x is greater than or equal to +1. +1 gets a filled in circle. Greater than goes to the right. Okay, you did it. You made it to the end of the review. Happy studying. You got this. Hang in there. One more semester and you're sophomores. Have a wonderful rest of whatever day it is for you. Bye.